जी सर, आप स्टार्ट कर सकते हैं।
Okay. Greetings, everyone. So now we are starting our week 5, and this is lecture 2. So in yesterday, we considered different classifications algorithm like logistic regression, decision tree, random forest, and there are different parameters, hyperparameters, when to use them, when not to use them, how to deal with underfitting or overfitting scenarios, how to check the data types, how to like which algorithm needs normalization or other transformation to get the results, how to evaluate the results of the matrices. In today's lecture, we will cover the next algorithms that are sport vector machines, k nearest neighbors, naive bayes, k means clustering. This is for unsupervised. When you don't have a labels present, then you will use a k means. And also we have covered this in our previous weeks: what is supervised learning, what is unsupervised learning, what is reinforcement learning, uh, what kind of data needs what kind of algorithm, and then how to develop these algorithms, right? And then there is a very known technique with excellent results, that is gradient boosting. But again, it really depends upon your data and the problem you are solving, right? So in 2 days, like, look, this is our tomorrow stuff. Like plotted a pair plots and other stuff, that how to use them. We will see. This is our comments, and this is our matrices. And here we explain what is the Gini index, what is entropy, what is the like how to choose the trees nodes, and how to how trees length will affect the decision. How what is the feature importance, and then we will use uh, move on towards random forest to check for bagging, bootstrap, aggregating, feature randomness, and etc. Now, today's we are going to work like uh, sport vectors machines. Yeah, and also okay, so now looks at the sport vector machines. So let's look at slightly more geometric approach. Sport vector machines are as such. Imagine you have a red balls and blue balls scattered on a table, and you need to separate them with a straight stick. Not only do you want to separate them, but you want to put the stick exactly in the middle, so it is so far away from both the red and blue balls as possible. The problem is classifying the red and blue boards separately. And the stake is what we call a hyperplane. The stake that we use to uh, cl- uh, to make a line that distinguish between red and blue balls. That is our example. That is called a hyperplane. Okay, and now after this explanation, we will look at visually what is a hyperplane, right? If I field a set boundary to separate classes in a feature space, it is especially affecting a high dimensional data. The stick is called hyperplane and hyperplane, and the distance between the stick and the closest part is called margin. Sport vector machine tries to maximize this margin. It wants to draw a boundary that is as distant and as safe as possible. If the data can't be separated by straight lines, sport vector machine uses something called kernel trick to project the data into higher dimensions, like tossing the balls into the air and sliding a sheet of paper between them while they are floating. So what everything means. Okay. The nearest points are called spot vectors. They maximize the margin because larger margins mean the decision boundary is more confidence and generalizes better to new data to avoid underfitting or overfitting. And that kernel trick, what is meant by kernel trick? Kernel trick is a like what if data is not linearly separable? No straight line can be separate the classes. SVM uses mathematical technique called kernel trick to project the data into higher dimension space where it becomes linearly separable. Common kernels, these are like, okay, so we will set these in a project by ourselves, right? Which kernel we are using: linear, radial basis function, or polynomial. So linear is no transformation work when data is already linearly separable. And RBF, the most popular, handles circular and complex boundaries. Think of as drawing circular region around the clusters. Clusters mean groups. Uses polynomial features to create curved boundaries. Polynomial in our linear algebra and calculus class, we have seen what is meant by polynomial, what is meant by these features, and also we use like polynomial distributions and stuff like that in our week 3. When to use it: high dimensional data, text classification, image classification, cases where the number of features is larger than number of samples, when you want to be very robust decision boundary. And what are the parameters? Regularization, low C means wide margin but misclassify more training points. High C means narrow margin, try to classify everything correctly, risk of overfitting. Kernel, like we read this like linear, polynomial, sigmoid, or radial basis function, RBF. Gamma for RBS controls the influence of each data point. High gamma is equal to each point has local influence. Low gamma is equal to each point has a okay broad internal. Now look at the code and we need to run all cells. Okay. Okay, so SVM, so one thing that, okay, so we need to comment this out so it works. Okay, so this we need to convert this into a text field. I need to delete this, right? Okay, now everything's okay. So this is the data set that we are using. Okay, this is our previous lecture stuff, and we need to run that again for. Okay, again there is an. So this is for random forest. Okay, so this is our. Okay, so these like we have continued, like we have seen what is our data set, what are the categories in our previous. So this is part two of the lecture. So as you remember in our previous lecture, we uses SVM model, like SVM, SVC kernel, and then this is a regularization parameter scale -1, and then this is a sensible default gamma probability true needed if you want to predict probability. Okay, and this is we are fitting a model on our training data, and then we are predicting on our test data to see if the model is generalized or contains any kind of under or overfitting. So SVM, so the accuracy is 96. In our previous model, the random forest has an accuracy of 94%. So it has a slightly more accurate than that. Okay. So what, like, look at it. Now we will see the different stuff like hyperplane and okay, let me zoom out a bit stuff. Okay. So this is our like petal length and petal width and species, and this is like a boundary hyperplane, and to spread these classification to spread these categories. So this plane is for this type of category, and then you can see that there is a hyperplane, and the hyperplane means like you have a dedicated boundary to separate the different classes. Oh, and let's so this is all for the sport वेक्टर मशीन्स. तो इसमें हमने क्या देखा कि हमारे पास एसवीएम है, इसमें डिसीजन ट्रीज, और इसमें हमने ये बाकी डिफरेंट चीज़ें देखी थी, लाइक मैच क्रिएट किस तरह, प्लॉट डिसीजंस, और ये जो चीज़ है लाइक स्कैटर प्लॉट, एक्सटेंड, 2ds डॉट 2d डॉट फिट ट्रांसफॉर्म, ये हमने ट्रांसफॉर्मेशन देखी थी। और इसमें हम क्या कर रहे हैं, इसमें हम दो फीचर्स देख रहे हैं टू प्लॉट दिस स्टफ। ओके, तो नेक्स्ट हमारे पास चीज़ आ जाती है, वो है के नियरेस्ट नेबर। जो हमारे पास के नियरेस्ट नेबर होते हैं ना, इज वन ऑफ द मोस्ट इंट्यूटिव मशीन लर्निंग एल्गोरिथम. It does not actually learn a model during training. Instead, it memorizes the entire training data set and make prediction. And what is meant by intuitive machine learning algorithm means you can uh, guess, you are like you can say about the results कि वो किस तरह आ रहे हैं, आपका मॉडल किस तरह काम कर रहा है, राइट? एंड देन द कोर आइडिया, इसमें क्या होगा? कोर आइडिया क्या है कि आपके पास, ओके, तो लेट मी के नियरेस्ट ओके, तो दिस इज वन एग्जांपल कि आप केयर नियरेस्ट नेबर काम किस तरह कर सकते हैं, आपके ये चीज़ें क्या होती है। तो इसमें एक सिंपल सी ट्रिक ये है कि आप उसे बताते हो कि भाई ये मेरे नेबर्स हैं और मुझे बताओ कि मैं कौन सी क्लास में फॉल करता हूँ। सो इसकी पहले कौन सी चीज़ यूज़ होती है। Find the k training example that are closest to it using a distance metric, usually Euclidean distance। और Euclidean distance हमने पढ़ा था, कब पढ़ा था, like linear algebra में x2 minus x1 whole square minus y2 minus y1 and then their whole square root, and we check the stuff how it deal with that। हमारे पास k क्या होता है, k मतलब होता है कि आपने कितने जो क्लोजेस्ट पॉइंट्स हैं उनको देखना है, राइट। आपने कितने के हैं उनको देखना है। फॉर एग्जांपल आप इस एग्जांपल में आ जाएं। अब इसमें क्या है, दो क्लासेस है, के क्या कर रहा है। अगर आपके पास के तीन है तो ये इसका सर्कल इतना होगा, एंड ये विल नो एग्जांपल टू क्लासिफाई दिस वन। के सेवन होगा मीन्स यू हैव वाइडर एरिया। चूजिंग के, अब ये चीज डिपेंड किस तरह करती है, हमने के किस तरह डिसाइड करना है। तो देयर आर रूल ऑफ थंब। के होता है स्टार्ट विद के, स्क्योर आउट एन पेयर एन इज अ ट्रेनिंग साइज, ऑलवेज ट्राई ऑड नंबर्स टू अवॉइड टाइज। एंड के हमारे पास के वन क्या होता है, के वन होगा बहुत ही सेंसिटिव, और के का कोई लार्जर नंबर होगा तो वो क्या करेगा, a disease smoother decision boundary तो होगी but that will underfit the stuff। lazy learning, KNN is a lazy learner because there is a no training phase, all the work happens at prediction time। this misses training fast but प्रिडिक्शन स्लो फॉर लार्जर सेट। ओके, तो हमने कल भी एक चीज देखी थी कि हम जो भी एल्गोरिदम देख रहे होते हैं उसकी एक कंस्ट्रेन होते हैं, लाइक कुछ रिसोर्स कंस्ट्रेन होते हैं कि आप किस टाइप ऑफ डेटा पे और किस साइज ऑफ डेटा पे वो काम करता है। आपके पास अगर डेटा सेट मीडियम साइज का है, आपके पास कॉलम ज्यादा है, तो एसवीएम विल डू अ बेटर थिंग। बट आपके पास अगर डेटा सेट जीबीज में है देन यू नीड टू वर्ड मूव टूवर्ड लाइक न्यूरल नेटवर्क्स और दैट काइंड ऑफ स्टफ। क्योंकि उस पे जो ये के एन एन और इनकी होगी फॉर एग्जांपल एप्लीकेशन और कॉस्ट दैट विल बी हाई होगी, और रिजल्ट्स आर नॉट दैट मच सेटिस्फाइंग, क्या ये अंडरनीथ पैटर्न्स नहीं फॉलो कर सकते। Although nearest neural networks are have a great accuracy, but they contain a black boxes। So everything, so every algorithm has their pros and cons। So lazy learner हम इसे क्यों कहते हैं? There is no training phase. All the work happens at a prediction time that makes training fast, but prediction slow। Okay, meant to use small to medium data sets when decision boundaries are complex and irregular as a strong baseline। Important always scale feature. It can entirely distance based as we see it here, right? The k and then this region boundary for k3 and k7, and then classifying the different type like this triangle and this star like class A or class B। So always scale your features first, okay। So we are using k5, then we are using this k nearest neighbor from our scikit-learn library। We use like this is a parameter number of neighbors, distance formula eclodian हम यूज कर रहे हैं, और आपके पास वेट कौन है, all neighbors won't equally alternate। so you have to see based on data this is eclodian। इसके अलावा there are other techniques like जिस तरह लीनियर अलजेब्रा में हमने देखा था there are other techniques that you use। Euclidean has its own pros and cons, its own formulas, but if uh, it does not satisfy, you can change the solution। You can like fine tune the models, or you can use or involve other stuff। KNN model dot fit x train scaled y train, remember KNN just memorizes data here, and y predict KNN accuracy KNN, and then this is stuff KNN 5 accuracy 93.33%। okay, finding the optimal k using a validation curve, we will try to different values of k and see which one perform best, okay। so this is stuff, this is effects of k on train or test। so as we see on the x-axis, as the number of k increases the accuracy decreases, right। so we need to find a balanced approach that make the model generalizable, not an overfitted model and not an underfitted model। so the model can behave well with an a real world scenario which gives us a less number of false positives or these kind of alarms, right। So you can see it here. As number of key increases, the accuracy has decreased, right? Okay. Next we have, okay. So this is about KNN, and next is our naive-based algorithm. So this is the KNN, right? So that is K for KNN neighbors. So and why we are like jumping one after another like to the next thing? Well, because there are a lot of machine learning algorithms. Every one came with its own pros and cons. So our goal is to build a thinking to select which one, right? Then we have naive. In our previous, we have a dedicated section during a lecture on Bayes theorem, like what is meant by posterior probability, prior probability, what is the effect when a new thing enters, and how it is used in healthcare. We have a complete study, so you can also see that. Now we can see what Bayes told us and when to use it. So the core idea about Bayes is that it is a probabilistic classifier based on Bayes theorem. It calculates the probability of each class given the observed feature and predict the class with highest probability. It calculates the probability of each class given the observed probabilities and with highest class, right? Okay. In plain English, the probability that a data point belongs to a class given its feature depends on how likely these features. Okay, so this is for if someone is new, they can use this, like this is for like what is meant by probability in this case. Okay, the naive part, the algorithm assumes that all features are independent. Look, everything comes with their own assumptions. So this comes like all features are independent of each other. This is rarely true in practical, like petal length and petal width of flowers are obviously correlated, but the algorithm still works surprisingly well despite this simplification. And then there is a Gaussian naive algorithm. They assume that the features of each class follows a Gaussian or normal distribution. That normal distribution means like you can apply empirical rule and you can like that kind of assumptions. This is a variant we use for continuous feature. When to use this? Test classification. Spam filtering is a classic example. Each word is a feature. When you have a large number of features and when uh, you have a limited training data, when training speed is critical, naive Bayes is extremely fast and real time prediction. और इसे हमने कब यूज नहीं करना, वो हमने तब नहीं करना जब हमारे पास जो फीचर्स होंगे, दो कॉलम्स होंगे, वो हैविली कोरिलेटेड होंगे, आपके पास इंडिपेंडेंस की assumption जो होगी वो वायलेट होगी, देन प्रोबेबिलिटी आउटपुट नीड टू बी वेल कैलिब्रेटेड. देन हमारे पास है की एडवांटेज. Key advantage क्या है? Okay, Naive-Bayes requires very little data to estimate parameter. Even with small data set, it can produce reasonable results. अगर ये हमारे पास कोई specific problem हो, for example, fire detection from the sensors और like healthcare में कि आपका workload किस तरह आएगा, तो you can use this. Because this is a probabilistic approach. They don't need that much of data, but it can give you great pictures about your dependent variable, how they can change with respect to your independent variable that are your features. Okay, so the accuracy for naive Bayes is 96.67%. And what the model learned means variance of each. So this is like mean values of each features per class, and this is class variance. Okay, and showing predicted probabilities from naive Bayes probability nb dot model dot predict, and this is stuff like आपकी actual values and the predicted values based on the model we have trained, like based on naive Bayes classifier. Okay, and if you sum up these things, it will be one, right? Okay. Then we have came across an unsupervised machine learning techniques. What is meant by unsupervised? Unsupervised means you don't have these columns. You don't know what thing is what thing is dependent or independent. So K means is an unsupervised learning algorithm. Unlike all the algorithm we have seen so far, it does not choose label. It tries to find structure in data on its own, grouping similar data points. तो ये हमारे पास कैसे काम करता है? ये आपके पास ऐसे काम करता है कि आपके पास डेटा होता है जिसके लेबल्स अवेलेबल नहीं होते, जो कि अनलेबल डेटा होता है। आपको नहीं पता होता कि वेदर ये कॉलम किस कॉलम के साथ है, कौन सा है। तो ये क्या करता है, ये उनको ना क्लस्टर बना देता है। जो आपके पास सिमिलर डेटा होता है उनको चंक्स में, ग्रुप्स में कन्वर्ट कर दे। द कोर आइडिया क्या है? यू टेल द एल्गोरिथम आई थिंक देयर आर के ग्रुप्स इन दिस डेटा, फाइंड देम। द एल्गोरिथम वर्क्स इटरेटिवली, initialize, randomly place k centroids cluster centers in a feature space, assign, update, repeat. So this is an iterative process. First, you randomly place k centroid. Centroid means कि आप कोई भी इस तरह का चीज दे दें। ओके, सो हम इधर देखते हैं। ओके, सो वी विल, सो दिस इज अ 3D प्लेन, राइट। और और हमने ये भी सीखा था कि ये हम जीजी प्लॉट में किस तरह, प्लॉटली में किस तरह बना सकते हैं। ओके, हमारे पास टी चार्ट क्या है? क्लस्टरिंग। सो ये हमारे पास अनलेबल्ड डेटा है, बट बेस्ड ऑन द द ग्रुप्स, हमने उसको क्या कर दिया, क्लासिफाई कर दिया इनटू थ्री डिफरेंट स्टफ। जब आपके पास अनस्ट्रक्चर्ड डेटा हो या ऐसा डेटा हो जो आपको नहीं पता कि इसके लेबल्स किस तरह है, तो आप क्या करते हैं, मशीन लर्निंग में कौन सी चीज़ यूज़ करते हैं? अनसुपरवाइज लर्निंग। और अनसुपरवाइज लर्निंग आप में कौन कौन सी टेक्निक आ सकती हैं? क्लस्टरिंग टेक्निक्स एंड अदर स्टफ लाइक क्लस्टरिंग के फिर आगे फर्दर टाइप्स आ जाती है। ओके, customer segmentation, group customers by purchasing behavior, document clustering group, image comprehension, reduction color by replacing similar ones with a centroid color, anomaly detection points far from a centroid are usual, and exploratory analysis when you do not have the labels. आपके पास नेक assign, assign, update and repeat. Choosing K क्या होता है? The biggest challenge, you must choose K in advance. The elbow method helps, लाइक हमने पीछे एक थंब मेथड पढ़ा था टू फाइंड द वैल्यू ऑफ के फॉर के नियरेस्ट नेबर। नाउ वी आर लुकिंग लाइक an elbow method. The run k means for different values of k, for each k, for each k compute the sum of square distances from each point to its centroid called inertia. Point out inertia versus k. The elbow and the curve where reduction in inertia slows down dramatically suggests the optimal k value. Sensitive to initial centroid, these are the limitations. Does not handle clusters with complex shapes as well as you. Clusters are roughly spherical and similar in size. So ये इसकी by assumptions हैं। और cluster alignment for fast samples, तो इसमें क्या किया हमने, डेटा दिया विदाउट एनी लेबल्स, और दिए हमें उसमें तीन क्लस्टर इसने बना के दे दिए। कौन किस तरह क्लस्टर्स बनाए? वी कैन सी इट हेयर। क्लस्टर इसने इस तरह बनाए, आपके पास पीटल लेंथ, ट्रिपल लेंथ जो भी है, वे चीज आपके क्लस्टर्स इस तरीके से बने। दिस इज द फर्स्ट क्लस्टर, दिस इज द सेकंड एंड दिस इज थर्ड क्लस्टर। तो इसने हमें तीन क्लस्टर्स बना के दे दिए हैं। एक्चुअल स्पीशीज लेबल्स ये हैं, और के मींस क्लस्टर्स हमारे पास ये बने। यू कैन से दैट द मॉडल परफॉर्म वेरी गुड ऑन दिस डेटा। और एल्बो मेथड किस तरह है? This is like for elbow method, elbow at k is equal to 3. They think that this is the point of intersection. You can say this is a 3. You can, but the optimal value of k for k by looking at number of clusters and inertia, like sum square of distance, you can find out that the k is 3 where they are overlapping. Okay, next, the thing we cover is, okay. So gradient boosting. So just 1 minute overview of this is that Like this is the most powerful algorithm in industry. And imagine you are taking a really difficult test. You take it once, you get some questions wrong. A friend looks at only your mistakes and studies specifically to correct them. Then a third friend looks at what the two of you still got wrong and focuses only on those. So gradient boosting does exactly this using decision trees. It builds a simple model, sees where it makes prediction errors, and then builds a second model specifically designed to correct the errors of the first. It does this sequentially, adding hundreds of weak learners together to create one incredible, strong, highly accurate supermodel. It learns directly from its own mistakes and making it favorite for complex real-world data science projects that needs a low number of false positive, right? So understanding this will give you a foundation to solve almost any standard data problems. And so again, gradient boosting is another ensemble method using, so ensemble method मतलब आपके पास क्या होगा, एक coordination होगी ensemble जो combine different methods. Unlike random forest which build trees in parallel independently, gradient boosting builds trees sequentially. Each new tree tries to correct the mistake of the previous ones. The core idea: imagine a student learning from mistakes. After the first exam, the teacher identifies which questions the student got wrong. The student then focuses specifically on those weak areas. After the second exam, they focusing on whatever is still wrong, and so on. And this repeated cycle will make that learning highly accurate. Gradient boosting does this mathematically. Start with a simple initial prediction, mean of target, calculate residuals, and these residuals means your mistakes, your errors, how wrong was prediction for each sample, and train a decision to predict those residuals, not the target directly, and add that tree's prediction to ensemble with a small multiplier called a learning rate and recalculate residential repeat. Each tree is small called a weak learner or sub but strong, but together they form a super full model. हमारे पास चीज हम दोबारा देख रहे हैं बोस्टिंग वर्सेस बैंगिंग। तो हमारे पास जो चीज होती है, आपके पास रेना फॉरेस्ट किस तरह काम करता है, पैरेलल होती है आपकी ट्री बिल्डिंग। ग्रेडियंट बूस्टिंग में सिक्वेंशियल होती है, लाइक पहले लोअर स्केल पे होती है, ईच फिक्सेस प्रीवियस एरर्स एंड देन मूव्स फॉरवर्ड। आपके पास बैगिंग में क्या होता है, रिड्यूस वेरिएंस होती है, रिड्यूस बोथ वेरिएंस एंड बायस। और कंप्यूट पावर किसकी ज्यादा होती है, लाइक फास्टर कौन होता है, रैंडम फॉरेस्ट। ग्रेडियंट बूस्टिंग स्लोअर होता है, स्लोअर क्यों होता है, बिकॉज इट गो बैक्स टू previous steps, solve that problem, and then make itself error free and then move toward next step. ओवरफिटिंग रिस्क लोअर होता है, इसमें ज़्यादा होता है क्योंकि ये अपना जो डेटा सेट होता है उसको मोर लाइक ओवरली इंजीनियर कर लेता है, बट इट डिपेंड्स अपॉन लाइक आप किस तरह उसको फाइन ट्यून कर रहे हैं, आपने इसे यूज़ कर करना है। When tabular structured data competition, this is often the window winning algorithm when you want to best possible accuracy and structured data, when you can afford longer training time and hyperparameter tuning. आपके पास n estimators क्या होते हैं, number of trees to build sequentially, how much each tree contributes, learning rate. More tree means more robust, like lower means more less trees needed. Typical range 0.1 to 0.3. Maximum depth is like the depth for that tree. Each of individual tree typically shallow 3-5 for boosting subsample. And okay, then हम इस कोड को देख लेते हैं। तो हम again we use an imported that classifier, और ये क्या करेगा, बाइनरी क्लासिफिकेशन का ओके करेगा, नंबर ऑफ एस्टिमेटर्स, लर्निंग रेट, सैंपल रैंडम टू रिप्रोड्यूस द स्टफ, फिट, this is the testing data predict, and gradient boosting has accuracy of 90%, right? And then we are looking for feature importance for gradient boosting. So feature importance, like again, in our previous algorithm, we have seen that petal width uh, outperform every other feature, like it is the most important, and petal width and petal length. And these are like some have minor feature importance. And effects of learning rate, we can visualize this and see what is the effect of learning rate. So you can see that the learning rate is almost like consistent throughout our data set. ओके, फाइनल कंपैरिजन एल्गोरिदम्स का हम क्या करेंगे, इनके रिजल्ट्स को देखेंगे। आपके पास सबसे ज़्यादा जो होगा, ओके, सबसे ज़्यादा अच्छा परफॉर्म किसने किया है, डिसीजन ट्रीज ने, डे बेस ने और एसवीएम ने। और फर्दर 93.3% केएनएन, लॉजिस्टिक रिग्रेशन, रैंडम फॉरेस्ट और ग्रेडियंट बूस्टिंग ने किया है। एल्गोरिदम कंपैरिजन ऑन आयरस डेटासेट टेस्ट। ओके, ये आपके पास चीज़ें आई हुई है। तो आपने सिलेक्शन गाइड क्या करनी है कि आपने कौन सा एल्गोरिदम कब और किस तरह यूज करना है। तो वो इस तरह होगा। सबसे पहले आपका लॉजिस्टिक, आपने सबसे पहले देखना है कि आपने काम कौन सा करना है, आपकी एंड गोल क्या है, प्रॉब्लम कौन सी सॉल्व करनी है। अगर बाइनरी क्लासिफिकेशन है, प्रोबेबिलिस्टिक आउटपुट है, यू कैन यूज लॉजिस्टिक रिग्रेशन विद सेगमॉइड फंक्शन। आपके पास एक्सप्लेनेबिलिटी, सिंपल रूल, डिसीजन ट्रीज, or what is meant by these are interpretable model. You know where your outcome is coming from, how it is calculated. And then random forest, general purpose, robust, partial feature, high dimensional data. You can use SVMs, small data sets, irregular boundaries, KNN, tags, real time, small data, day based approach. Then gradient boosting for on tabular data, partial feature importance, and why the gradient boosting not perform in our case very well, because it assumes there is no correlation between variable, but in our case there is a correlation between petal width and petal length. And these are the concepts. We again looking at overfitting, underfitting. Overfitting model learns the training data too well, but fails to deliver results on just a real world data. Underfitting means model is too simple to both give good results on training data as well as testing data for uh, it is not a generalizable model. Bias variance trade-off क्या होती है, simple models have high bias and complex like models have high variance overfitting. Good ML are fitting in a sweet spot like this. And then supervised versus unsupervised, no label goal, final structures. And we need to add one more thing here, that is reinforcement. Okay, so what does reinforcement learning means? Reinforcement learning means that you have an agent environment, and then agent learn based on reward system, राइट। पास एक एजेंट होता है, वो चीजों को लर्न करता है बेस्ड ऑन रिवॉर्ड सिस्टम। फीचर स्केलिंग क्या होती है, ब्रिंगिंग ऑल फीचर्स टू सिमिलर रेंज। और ये हमारे पास रिइंफोर्समेंट लर्निंग किधर यूज होती है, ये हमारे पास लाइक इन ऑटोनोमस सिस्टम्स में यूज होती है फॉर सेल्फ ड्राइविंग कार्स और स्टफ। वो सिस्टम जो एनवायरनमेंट में आते हैं, फॉर एग्जांपल रोबोटिक्स में यूज होती है। ओके, फीचर स्केलिंग क्या होती है, ब्रिंगिंग ऑल फीचर्स टू स्मॉलर रेंज, required for distance-based algorithms or required for tree-based algorithms. And train, test, split, always evaluate the data. The model has never seen this simulates real-world performance. So this is our end of lecture in which you encounter like most of stuff. To recap, this stuff like understanding these concepts gives you the foundation to solve almost any standard data problem. In our next session we will look one of the algorithm actually. Okay, so we have looked here and then build a simple models, and but like this is for hyperplanes, for SVMs, like feature importance. Okay, so this is everything that we have done so far. Okay, and then we are About to. So let me remind that this is advanced statistics course, advanced statistics with projects course, right? This is week 5, lecture 2 by me and our moderator. Thanks to them that was saying. Okay, so this is some of our background. You can use this information to easily find the results. Okay, so if anyone has the questions, we can move forward, or if not, then also we can like uh, stop our live streaming.
जी सर, आई होप के कोई क्वेश्चन नहीं है. Let me end the live stream.